Dear all, welcome to ACE Online, digital platform of ACE Engineering Academy. This is Dr. G. Balaraju, Professor of Mechanical Engineering from ACE Engineering Academy. So in the present video, I would like to discuss answers for memory-based questions. So as you know, today exam held and we received some questions. We are not sure about exact data based upon the students like a memory and like a few students only sent number of questions. So based upon the available data, we are trying to present the solutions. Again, I am telling you, we are not sure about the exact data. Only based upon the memory based, only based upon memory, we are answering the questions. And there is a possibility of some deviations. So there is a possibility of some deviations. And when you see the weight, like a weightage, and we had three streams, like a production, design, and thermal. In production this time, 24 marks, material science and metal cutting science, machine tools, advanced machining methods, IM and WAR, all together in production, around 24 marks. In design stream, as you know that engineering mechanics, strength of materials, machine design and theory of machines, all together 24 marks. And thermal stream, fluid mechanics, basic thermodynamics and applied thermodynamics, heat transfer, okay, from there 24 marks. So this time 24, 24, 24, three streams equally divided. And when you see the questions are little bit lengthy but easy. So if you look at thermal questions, so thermal questions are quite easy and a few questions are lengthy. And in production, so most of the questions are straightforward. And similarly in strength of materials and machine design somewhat tough, and even engineering mechanics, we could not get a correct data from the students. Okay, based upon only the available data, we are trying to present. And if you see the weightage from subject wise, so production technology, so in production technology, it could be like metal cutting, metal casting, welding, forming, sheet metal works altogether. So there were 5 questions of 2 marks and 5 questions of 1 mark. And thermal engineering, so 4 2 marks questions and 2 1 mark questions. Heat transfer, so this time almost based upon the data, we had almost 9 marks weightage. So highest weightage for heat transfer. In fluid mechanics and turbo machinery, so 2 marks questions of 2 questions are there and 1 mark question only 1. So the weightage is 5 marks. Theory of machines, 3 2 marks questions and 2 1 mark questions. The weightage, so 8 marks. From strength of materials, 3 2 marks questions. Machine design, less weightage this time, only 4 marks. IM and WAR, 3 2 marks questions and 2 1 mark question. Engineering mechanics, so 2 2 marks questions and 2 1 mark questions. Actually in engineering mechanics, highest weightage now, almost here 6. Normally we used to get only 2 to 3 marks, but this time we had more weightage. Engineering materials as usual like 1 mark, but generally we expect 2 marks. Last year we had many questions, but this year only 1 mark. Engineering mathematics 13 marks, so standard. So 4 questions of 2 marks and 5 questions of 1 mark, and aptitude of course you know very well. And if you see the total 65 questions out of 65, so what kind of questions we had? NET type 24, MCQ 39 questions, MSQ 2 questions. So whatever we are going to present, so purely based upon the memory. So exact data we may not be having, and even I am not assuring you that the answers are correct. Only based upon the data we received from you, we are presenting. Even if you have any data, so please do upload. So then we will give solutions, and it is going to be helpful to you. Right now, assessment type, like based upon the questions only, we could give the solutions, and we request you, If you have any data or you are able to remember any data, just try to send, and definitely we are going to add that and we will be presenting in better manner. Okay. So next, so I request, so my faculty member Mr. Rajesh, he is going to give the solutions related to aptitude.
Hi everyone. From the aptitude, as you know, 15 marks weightage including English and numerical ability. Out of that 15, numerical ability, 7 questions, 7 to 8 questions. One question from the, as we discussed as previously in our classrooms and online and recording version also. So pie chart, data interpretation. Next from the spatial aptitude, paper folding is also given. And probability questions, one question is given. Okay, based on the given data, okay, we are getting some questions only, my dear friends, only some questions. So from that, one question observe, which of the following should be removed in the order to get a Fibonacci series? So Fibonacci series means sum of the two numbers, sum of the preceding two numbers, then you get a next number. Suppose 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, but 6 is wrong. Okay, that 6 is a wrong number in that series. So 2 plus 3, 5. You can 3 plus 5, 8, 8 5, 8, 13, 8 to 13, 21. So what is the wrong here? 6 is the wrong. Next, which of the following odd given series? Okay, odd man out. So what is the odd man out? Very easy question, my dear friends, very easy. So easily we are getting the concept. 19, 37, 21, 17, 23, 29, 31, 11. So first priority already I mentioned, we are mentioned. First priority prime numbers. You can observe the numbers. So 21 is not a prime number. Remaining everything is also prime numbers. So this is odd man out. Okay, friends. Okay, only 2 questions we are receiving from you. Okay, remaining questions are lengthy. Okay, if you are getting a good data, immediately you can share. Okay, friends. Next. Our faculty next materials will continue.
Right. So from engineering materials, as usual, we expected one question from the iron cemented phase diagram. So this is a question, the phases of perlite. So perlite is an iron carbon alloy that consists of 0.8% of carbon. In perlite, okay, thin lamellar form of cementite, and surrounded by that alpha iron is there or ferrite is there. So this is cementite, Fe3C. This is alpha iron, right? So perlite is a mixture of ferrite and cementite. So B is the correct answer. It's a very simple question, right? Now the next is actually from sheet metal operation. This time From the sheet metal operations, 2 questions they asked, they are very easy questions they asked. See, in which of the given below operation earring defects are observed? Earring defects are observed in, okay, deep drawing operation. It's a very simple question. Earring defects are observed in deep drawing operation, right. Next, another simple question. In a blanking operation is performed on C20 steel sheet to obtain a circular disc having a diameter of 20 mm and a thickness of 2 mm, a clearance of 0.04 mm is provided. Okay, the data quality is 0.04 mm is provided. The punch size is used for the operation. See, remember, punch size is equal to die size minus 2 into radial clearance. Okay, na? So here die size is nothing but it's a blanking operation. It's a blanking operation, right? So diameter of the die is 20 mm is given. So die size is 20. Die size is 20 minus clearance is given 0.04. So 2 into 0.04, right? So from this you will get 19.92 mm is the punch size. So this is a memory based question. We don't know exactly at what is the clearance, all this, is it radial clearance or diametrical clearance, but based on the given data I am giving the solution. So this is the solution for this question, right. Next our faculty will continue. Right. So from the machine design, 4 questions they asked and 3 numerical questions and 1 theoretical type question. Now here a simple band brake is represented as shown in the figure. The drum is rotating in clockwise direction and the coefficient of friction between the contacting surface is 0.3. The angle of wrap is 180 degrees. The maximum tension is 1.5 kilonewton. Then the load required for the operation. See, I am directly giving the solution because our colleague faculty gave this answer and they will give a detailed explanation later. So answer for this question is 0.117 kilonewton. 0.117 kilonewton. This is the one question, right? And the next question, here it is. Next question, wait. Right, okay. Next question, here it is. A shaft of diameter 50 mm is subjected to axial load of 10 kilonewton and a twisting moment of 600 Newton meter, if the tensile yield strength of the material is 300 megapascal, the factor of safety according to the distortion energy theory. So, the factor of safety according to the distortion energy theory, that is approximately 4.53 is the correct answer. 4.53 is the correct answer. 4.53 is the correct answer. So, the question here, it is theoretical type question. The most safest or conservative theory is Soderberg theory. The most safest and conservative theory is Soderberg theory. So, 3 questions they asked, 2 numericals and 1 theoretical question.
Hi, myself P. Venkatrao, Mathematics Faculty, ACE Engineering Academy. Actually, as of now, we have just received 4 questions from Engineering Mathematics, but generally from Engineering Mathematics, we will be given 8 questions. As of now, we received only 4 questions and we will be going to discuss these 4 questions. The first question from complex variables, as you are aware of it, which is also an important model. Suppose f of z equal to u plus iv is an analytic function and we were given the real part u and we were asked to find instead of finding the imaginary part v, we were asked to find f of z equal to u plus iv completely in terms of z. So first of all, we were given u equal to cos hx into cos y. F of z equal to u plus iv analytic function, real part u given, we should not find the imaginary part v separately. Instead, we have to find f of z equal to u plus iv completely in terms of z. So for that, we have to find dou u by dou x. Cos hx derivative sin hx cos y, and dou u by dou y, we can also read it as del u by del y, that is cos y derivative minus sin y. So minus cos hx sin y. So what is the formula to find f of z in terms of z? As you are aware of it, f dash of z equal to dou u by dou x plus I into dou v by dou x. By Cauchy-Riemann equations, v suffix x means dou v by dou x should also be written as minus dou u by dou y. So from this, dou u by dou x minus I into dou u by dou y. One extra page. this is the formula. You just have to substitute dou u by dou x and dou u by dou y. So from this, f prime z f dash of z equal to dou u by dou x, that is sin hx cos y minus psi into dou u by dou y. Minus psi into dou u by dou y is this, minus into this minus plus psi plus psi cos hx sin y. Putting x equal to z and y equal to 0. Substitute x equal to z and y equal to 0. If you take y equal to 0, then this part becomes 0 because sin 0 0. If you take y 0, cos 0 1 and x z, therefore f dash of z equal to sin hz. F dash of z equal to sin hz. Integrate both sides. On integrating both sides, you will get f of z equal to integral sin hz, that would be cos hz plus c. This is the answer. So if u equal to cos hx into sin y, then f of z equal to u plus iv completely in terms of z would be cos hz. Next. One problem from differential equations, that is from linear differential equation. Simple problem given. According to the given data, we are not aware of what the condition given. Actually, we were not given, actually we know condition is there, but as we received what the condition x of 1 equal to how much exactly not known. Anyhow, so first of all, the given differential equation is t into dx by dt plus t minus x equal to 0. So divide both sides by t, then it becomes dx by dt plus 1 minus x by t equal to 0. Take this plus 1 to the right side in order to get it in the form of linear differential equation dy by dx plus py equal to q. So from this, dx by dt minus x by t equal to minus 1. What is the integrating factor? 1 by t. Or if you solve as per the procedure, integrating factor you will get like this, e power integral p dt, p value minus 1 by t. So this is minus 1 by t dt, that is e to the power of minus ln t, that is 1 by t. So integrating factor 1 by t. What would be the general solution? General solution x into integrating factor. So x into integrating factor is x into 1 by t equal to integral capital Q. Capital Q means minus 1 into 1 by t dt. So from this x by t equal to minus ln t, integration completed, add some constant. Suppose you are given a condition, for example this condition we are not aware of it as we received the data from the students. In case x of 1 equal to 2, for example we consider x of 1 equal to 2, that means x value 2 and t value, x value 2, t value 1. By substituting x value 2, t value 1, if you take x value 2, t value 1, it becomes 2 equal to minus ln 1, that is 0c. Condition I don't know exactly, randomly, because I did not receive any condition regarding from the students. That's why randomly if I assume x of 1 equal to t, x of 1 equal to 2, that is x2 and t value 1, this is the c value. So from this, x by t equal to minus ln t plus c, c value 2. Then what we were asked? We were asked to find x of t when t equal to 2. So substitute t equal to 2. So x by 2 equal to minus ln 2 plus 2. Multiply both sides by 2, x equal to minus 2 ln 2 plus 2 2s are 4. And we are not aware of that whether it is MCQ or fill in the blank question. In case MCQ, that is fine. In case it is fill in the blank question, then you have to find ln 2 and it should be multiplied by minus 2 plus 4 and then you have to simplify, then we have to write. And observe this question carefully. Suppose A equal to 1 alpha 83, then the value of alpha for non-positive eigenvalue, we all know that sum of the eigenvalues equal to sum of the diagonal elements, I mean trace of a matrix. For example, we assume lambda 1 and lambda 2 are the eigenvalues, then sum of the eigenvalues must be trace of a matrix, means sum of the diagonal elements, that should be 4. And moreover, product of the eigenvalues equal to determinant of a matrix. So determinant of a matrix equal to product of the eigenvalues. Product of the eigenvalues is lambda 1 into lambda 2. What is the determinant of the matrix? That is 3 minus 8 lambda. 3 minus 8 lambda equal to lambda 1 into lambda 2. And now you read the question carefully. The value of alpha for which alpha value corresponding to non-positive eigenvalue, means alpha value corresponding to, remember non-positive means it should not be positive. So it should be either 0 or it should be negative. For example, you assume it is negative, then product of the eigenvalues is negative. Both eigenvalues negative, it is not possible because corresponding to which negative eigenvalue we have to find alpha value. That's an ambiguity. So definitely only one eigenvalue must be negative and another eigenvalue must be either positive or 0. So here if you assume only one of the eigenvalue is negative, then product of the eigenvalues must be negative. Otherwise it is 0. If it is 0, in case if eigenvalue 0, then 3 minus 8 lambda equal to 0, so 3 equal to 8 lambda, so that lambda equal to 3 by 8. In case lambda value negative, I mean one of the eigenvalue negative, 3 minus 8 lambda less than 0, so 3 less than 8 lambda, so 3 by 8, 3 minus 8 lambda less than 0, so that is 3 less than 8 lambda, that is 8 lambda greater than 3. So therefore lambda greater than 3 by 8. If lambda value greater than 3 by 8, then the question should not be given as for what value of alpha it should be a non-positive eigenvalue. It should not be given like that. Then it should be given as for what value of alpha, what is the least positive eigenvalue, non-positive eigenvalue. So what is then it should be given as what is the minimum possible eigenvalue, because greater than meant for minimum, greater than or equal to means minimum. But there is some ambiguity regarding the question. Question is fine, but the problem is according to the data we received, we are getting lambda value 3 by 8. Then the question should be given as the value of alpha, here alpha value 3 minus 8 alpha, 3 minus 8 alpha, so alpha value 3 by 8. Then it should be given as the least value of alpha. The least value of alpha it should be given, but they did not give. So there is some ambiguity in the question, I mean regarding the statement. Now you observe one problem has been given from multiple integrals, but it's a simple question. The value of this double integral is logarithm of a by 24. Then what would be the value of a? It's very simple. First, all integral limits are constant limits, then order of integration is not important. That means you can integrate first y and then x, or you may integrate first x and then y. I am integrating with respect to y right now. When you are integrating with respect to y, at that time y is only the variable, other variable x must be kept constant. Here other variable x is there, that is kept constant. So this is x limits 3 to 4 and assume here x a constant. So k plus y whole square, integral dy by k plus y whole square, how much it is? Minus 1 by k plus y. Minus 1 by k plus y, k means x, x plus y, between the limits y equal to 1 to 2 into dx. Now replace y by upper limit 2 minus y by lower limit 1. Therefore it becomes x limits 3 to 4 minus 1 by x plus 2. Minus replace y by lower limit 1, then it becomes minus 1 by x plus 1. This is equal to integral 3 to 4 minus into minus plus 1 by x plus 1 minus 1 by x plus 2 dx. Integral 1 by x plus 1, that is ln x plus 1, integral 1 by x plus 2, that is ln x plus 2, between the limits 3 to 4. Replace x by upper limit 4, 4 plus 1 5, minus 4 plus 2 6, minus replace x by lower limit 3, 3 plus 1 4, ln 4 minus ln 5. This is ln A minus ln B, that is ln A by B. ln 5 by 6 minus ln 4 by 5. And again ln A minus ln B, that is ln A by B. So ln of 5 by 6 by 4 by 5, that is equal to ln 25 by 24. What the data given? Please verify. If you evaluate that double integral, you will get it as ln A by 24, then what would be the value of A? And observe this, the value of that double integral is ln A by 24. What is the value of A? 25. Therefore, A equal to 25. So as of now, we have received just 4 questions. I think still 4 more questions are there. Once the questions as we receive, then it will be updated soon. Thank you. Next, my colleague Keshav Reddy sir will continue strength of materials. Thank you.
Hi students, good evening. We will discuss strength of material questions. We have received as of now 3 2 marks questions. Look at this question. It is multiple select question, more than one correct answer for this, which is statically indeterminate. they are asking you which is statically indeterminate. You see this first option, more than 2 supports. So this is indeterminate. And look at this is a propped cantilever with the overhang. This is also indeterminate. This is also a propped cantilever with loading and all nowhere related to us, propped cantilever indeterminate. So this is a overhang beam on one side, this is a determinate. So indeterminate are options A, B, C. So answer is 1, 2, 3. A, B, C are the correct options. Now look at this question, very simple question. If you remember the formula, they are asking you maximum bending moment. If you assume that the loading is W and the span L is equal to 1200 meter, nothing but 1.2 meter, the maximum bending moment, if you remember, bending moment maximum, it is a standard question. If you want to derive, it takes more than 3 minutes of time, and if you remember this is WL square by 9 root 3. W is 100, L is 1.2 whole square by 9 root 3. If you remember this formula, it is very simple, very silly. It is 9.23. 9.23 kilonewton meter. Simple, straightforward, 2 marks question. Next, coming to this question, this is related to thin cylinder. A thin cylinder closed at ends. Once it is closed at ends, then only you will get internal pressure inside. So the internal pressure is 0.2 megapascal. This is P given to us. And the diameter is given as 200 mm and the thickness is given as 20 mm. What is the normal stress on weld? There is a weld here at an angle of 30 degrees with vertical and 60 degrees with horizontal. This normal stress they are asking you. So if you look at this element, there will be tension in the length direction. This is longitudinal stress, and there will be tension in the circumferential direction. So this is sigma h. You know that sigma h is PD by 2T and it is PD by 4T. PD by 2T value I am directly giving you. It is 20 megapascal and it is 10 megapascal. So they are asking you stress on an inclined plane. If you want to calculate stress on an inclined plane, sigma theta, theta with vertical will take as per our standard formula is concerned, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Theta is angle with vertical plus tau xy sin 2 theta, no shear on the element, no shear on this regular element. So we will substitute sigma x, you can substitute it as 10, sigma y you substitute it as 20 by 2 and 10 minus 20 by 2 cos of 2 into 30, theta is 30. So cos of 2 into 30 is cos 60, cos 60 is 1 by 2, you can simplify this. So this is 10 plus 20, 30 by 2, 15 plus minus 10 by 2 is 5 by 2. So this is 12.5 megapascal. This is normal stress on the weld. So these are the 3 questions came in strength of material as of now. There may be more questions on this. Once the question paper comes out, we will discuss about those questions separately. Thank you.
theory of machines question, in theory of machines guys, there were 5 questions asked. So here is the first question from flywheels chapter. The maximum fluctuation of energy in the flywheel is 300 joules, and the maximum and minimum speeds of flywheel are 280 and 220 radians per second. The coefficient of fluctuation in speed is given as 0.03, and change in kinetic energy, its inertia of the flywheel we have to solve. Inertia of flywheel. So a standard formula is available for this, that is delta Ke max is equal to I times of omega average square times of Cs. Okay, so Ke max is 300 and I will be, we need to calculate, and omega average will be average of these two values, maximum and minimum, that is 280 plus 220 is 500, 500 by 2 is 250. So this will be 250 square into Cs guys. So Cs is 0.03. Cs is 0.03, so you can solve here for I. Okay. So simple calculation. I am going to the next question. Units of I will be in kg meter square. Next question is from the gear train chapter. A planetary gear train is shown in figure. The number of teeth on gear 2 and gear 3 are 19 and 24 respectively. Module is 8 mm, and if gear 2 is fixed, and yes, the speed of gear 2 is fixed, n2 is equal to 0, and we are required to find out the angular speed of the arm. Okay, we are required to find the angular speed of the arm, and yes, so here we can write the direct expression for train value. That is, train value we can write it between gear 2 is in mesh with 3, 3 is in mesh with 4, so we can write it for train value for, that is, speed of 4 minus speed of arm divided by speed of 2 minus speed of arm is equal to the sense of rotation of 2 and 3 will be opposite, whereas 3 and 4 it will be same, because 3 and 4 there is an extra internal gearing. So the sense of rotation between 2 and 4 it is going to be opposite. Between 2 and 3 there is external gearing, and between 3 and 4 it is internal gearing. So the direction of 4 and 3 will be same, but it will be against 2. So this will be minus Z2 by Z4, it will be minus Z2 by Z4. Here the gear 3 is going to act as an idler. So that is why we are not able to see the teeth values of gear 3 in the expression of train value. Alright, so I think here the data of gear 2 is given, but we are required to find out the speed of arm, and the data for N4 is missing. Data for N4 is missing, so that is why I will be able to solve the problem only half, and the teeth of 2 is given as 19, and we can calculate the teeth of 4 by writing the relationship between the radii. So radius of 4 is equal to radius of 2 plus diameter, or 2 times the radius of 3 it is. So this can be, since all the gears are in direct mesh, so they should be having same module, which means that the teeth of 4 is equal to teeth of 2 plus 2 times of teeth of 3, which is equal to 19 plus 2 times of 24, which is equal to 67 it will be. That is 48 plus 19 is 67. So this will be 60. So whatever the value of N4 has to be given over there. So after, once we have the value of N4, then only we can get the value of N arm. So this will be the formula which we will be using to solve for the velocity of arm. Alright, so this was one question. Second question from the theory of machine. Next is, another question is from the vibrations chapter. A pulley of mass is shown in figure. Mass equal to 10 kg and K is equal to 1.5 kilonewton per meter. The frequency at which the oscillations of mass will be very large. Indirectly they are asking us to calculate the natural frequency, omega, and they are asking us to calculate. Okay. Now here if you understand the arrangement, the problem seems to be little complex, and these are two massless pulleys given to us, and there is a block connected to the pulley at the bottom, and there is a spring attached here. So here we have the higher pair here between the rope and pulley. There is a higher pair. So we have to take the here we have to assume the pure rolling motion between the rope and pulley, and about this point we can take the moments. So this point will be treated as the eye center, and about this point we are supposed to take the moments. So let me draw the free body diagram. So free body diagram of that pulley, here it will be mass, there will be mass or inertia force will be there, that is mx double dot, okay, and similarly, and if we are giving the displacement to the spring in the upward direction, inertia force is going to act downwards, and the spring force at the down spring, at this side of the spring there will be another spring force. Let me say this is k times of x. So this block is attached at the center of disc, okay. So let us say that if the displacement at this point is x and another spring is connected via rope, okay, it is connected on the outer circumference. So this spring is going to experience 2 times of x, okay. So this spring will be experiencing 2 times of x displacement it would be. So this will be k times of 2x, and at the bottom side we have spring as 2k. So this will be 2k x it will be, and this will be k times of 2x. So in the in this pulley, this will be the higher pair, and about this point we are supposed to take the moments, okay. So if we take the moments about this point, okay, let me correct here, this spring is going to experience the stretching. Yes, we can transfer here the same spring force on the rope. So we are giving the stretching towards upwards, which means the direction of spring force has to be corrected. It should be downward, guys. It should be downward. Okay. This will be the direction of spring force. All right. So now, if we take the moments about the point of contact, moments about point of contact, this will be the point of contact. It will be mx double dot into perpendicular distance is r plus 2k is the spring stiffness into x is the spring force into perpendicular distance is r plus the spring which is on the circumference. It will be having stiffness k, and this will be 2 times of x, and perpendicular distance will be 2 times of r. It will be, guys. It will be 2 times of r. It will be 2 times of r is equal to 0. So we get an equation of motion. X here will be equal to r times of theta. X will be equal to r times of theta. So this will be equal to, that is m into theta double dot, because r will be cancelled here, and this will be 2 times of r theta, r will be cancelled, this will be k, and this will be 4 times of k theta equal to 0. So this will be theta double dot plus 6k by m theta equal to 0. So k is given to us, guys, that is 1.5, and m is given to us as 10. So do the substitution, you will be getting this as around omega n is equal to root over 6 into 1.5 into 10 power 3 divided by, this will be 10 kg. So this will be equal to 6 into 1.5 is 9, under root of 9 is 3, and this will be 10 power 2, under root is 10. So this will be 30 radians per second will be the answer. Okay, 30 radians per second is the answer. So this is the first question from the vibrations chapter. And let us see another question. Yes, another question is from the velocity analysis, and a mechanism shown in figure, the angular velocity of link ABC, they are asking us to find out. So link ABC is in the triangular shape, and the angular velocity of link OC or link OP is given as 7 radians per second. So guys, if you observe this mechanism is similar to crank slotted lever mechanism. The change only here is that they have, instead of giving the slotted lever, they have given a triangular link, and on that a slotted hole is cut. All right. So now, based on the direction of omega, I mean the link OP is going to have the velocity towards left hand side. Okay. So this will be velocity of P with respect to O, which we can write it as velocity of P with respect to O will be equal to OP into omega. So OP is given to us as 150 into omega is given as 7. So this will be 1050 mm per second. All right. And similarly, they are asking us to calculate the angular velocity of link ABC. So now we can resolve this velocity along the slotted bar and perpendicular to the slotted bar. So along the slotted bar, it will be This will be the velocity along the slotted bar and perpendicular to the slotted bar. So this angle is 60 degrees, so obviously this angle will be also 60 degrees. Now we need to measure the perpendicular distance of this vector, this is velocity of point P with respect to A. Velocity of point B with respect to A. So we need to measure this perpendicular distance. So let me join here. So this is going to be 90 degrees beta. This is going to be 90 degrees, and we know very well this distance from P to A is 150. From P to A we know it is 150. So this angle is going to be, this is 30 degrees, so this will be 30 degrees, and this will be 30 degrees, and this will be 150 sine 30. The perpendicular distance will be 150 sine 30, alright. Perpendicular distance from this velocity vector from point A will be 150 sine 30. So here we can write this as this velocity of P with respect to A is equal to velocity of P with respect to O into sine of 60 degrees it is, into sine of 60 degrees. So velocity of P with respect to A is given to us as AP into, that is velocity of P with respect to A. The perpendicular distance we have measured, that is 150 sine 30, 150 sine 30 into omega of link ABC, omega of link ABC. This is equal to velocity of P with respect to O, which is given as 150 into sine 7 it is, and this is into sine 60 is root 3 by 2 guys. This is root 3 by 2. So 150 will be cancelled, and this is sine 30 is 1 by 2. This is 1 by 2. So this is 1 by 2 into omega ABC is equal to, this is 7 root 3 by 2. So omega ABC will be equal to 7 times of root 3 guys. So which is slightly greater than 10 or 11, 12 radians per second would be the answer for this one. Okay, very simple question. And the next one is a free damped system. Following parameters are given. So mass is given to us as 2 kgs, natural frequency that is 15 hertz, and successive amplitudes are, this is the amplitude after first cycle, that is 7.75 mm, and the another amplitude is 7.20. Okay, we are required to find out the damping coefficient in Newton second per meter. So what we can do here is we can directly formulas we can use, the relations which is available. Critical damping is equal to 2 times of m omega n, and this is the undamped natural frequency given to us, which is Fn, which is equal to 15 hertz. Okay, so we get this as 2 into mass is given as 2 kgs into omega n is 2 pi into Fn. If we are converting this into radians per second, multiply with 2 pi. So this will be 2 pi into 15. So this will be the expression for critical damping, that is 2 into 2 into 15, 460, 60, and this is 120 pi Newton second per meter will be the critical damping. And we are required to find out the actual damping coefficient. So actual damping coefficient, we need to make use of the logarithmic decrement. That is delta is equal to log of 7.75 divided by 7.2 is equal to 2 pi zeta by 1 minus zeta square. So anyway zeta, this is an underdamped vibration, so which means zeta value will be definitely less than 1. So higher powers of zeta can be ignored, and we can solve here. That is zeta is equal to, that is log of 7.75 divided by 7.02 divided by 2 pi. So from here we get zeta value, and zeta can be also written as, or this can be equated to C by Cc, or C by Cc is nothing but 2 root mk or 2m omega n. So when you solve for this, you will get the value of C. Okay, so you can do that calculation. So these are the questions from theory of machines. Alright, next my colleague is going to take over the discussion.
evening. Let us start questions from fluid mechanics. We have 3 questions from basic fluid mechanics. This first question is from dimension analysis. The question says a liquid filled in a horizontal capillary tube whose one end is dipped in a large pool of liquid. Experiment shows that the distance L travelled by the liquid meniscus inside the capillary in time t is given as L is equal to K times gamma A. Gamma over here is surface tension, please don't be confused. Radius RB, mu C, mu is viscosity, root over of T. Find the value of A, they are saying. Now by dimension analysis I can say over here, K anyway is a constant. So dimensions of length is L, L power 1 is equal to dimensions of surface tension dimensions will be mass m and T power minus 2 whole power A. Radius is going to have dimensions of L, L power B. Viscosity will have m L power minus 1 T power minus 1 whole power C and T power half. This is what we are having. So if you compare mass power over here is 0, so this implies 0 is equal to A plus C. Length power over here we are having is 1. This implies 1 is equal to, if you check over here, 1 is equal to B minus C, and you are having time t power 0, which implies 0 is equal to minus 2A minus C plus half. Now you are having 3 equations and 3 unknowns. You can solve these 3 equations. Eventually you are going to get the value of A is equal to half. This is the first question we are having. Let us move further to the next question. Look at this question. Now this question is saying in a pipe network all pipes have same cross section area. Mind you, the cross section areas are same and they are assumed to have the same friction factor. So same friction factor. The pipe connecting points. Now look at this network over here. They are saying that we are having 4 ends over here, north, east, south, west. This is a particular junction. The length from north to junction is L, junction to S is L, west to junction is L. From junction to east is equal to 10L. The influx is in this particular direction. So from west to junction influx is coming in, and in every other pipe we are having efflux taking place. There is efflux taking place over here. Now the question is saying the pressure at N, E and S are equal. All these pressures over here are equal. The flow rate in the pipe connecting W and J is equal to Q. This flow rate is equal to Q, he is saying. Okay. Assume steady flow, incompressible flow, and the pressure loss in the pipe entrance and junction are negligible. The question over here is which of these options or multiple options are correct. Option 1 over here, flow rate in the pipe J to E is equal to Q upon 21. Now how do we solve this thing? If you observe over here, guarantee for sure the head loss in J to S, J to N and J to E is supposed to be same. The reason being pressure drops are same. So therefore we can say all these head losses are equal over here. And if we are having some discharge over here, Q, let us say for example, or Q prime let us say, okay, the discharge over here is Q prime. Now we can compare these 2 discharges by the relationship that head loss is proportional to length times Q square, which implies 10L times Q prime square is equal to, let us say the discharge in this pipe and this pipe both should be equal because lengths are same. This discharge let us say is equal to Q double prime. It should be equal to length times Q double prime. This implies the value of Q prime is supposed to be equal to, or Q double prime let us say is supposed to be equal to how much? It is supposed to be equal to root 10 times Q prime. Once we have this relationship, now we can say influx must be equal to efflux. Influx is equal to Q over here, efflux over here is equal to Q double prime plus Q double prime plus Q prime. Q double prime plus Q double prime is equal to 2 times root 10 Q plus Q prime, one second, plus Q prime is this much. The value of Q prime from here, if you see, it will come out to be equal to Q divided by 1 plus 2 root 10. The value over here should be Q divided by 1 plus 2 root 10, but they have given Q upon 21. This is a wrong statement. Look at the second statement over here. The statement is the pressure difference between J and N is equal to the pressure difference between J and E. J and N, J at E, the pressure difference is same. That is correct because he has mentioned this point and this point are having same pressure. So this statement over here is correct. This is the second question we are having. Let us move further to the next question. Now this question, as usual, you were expecting a question from continuity equation. We have a question over here. The question says an incompressible 2D flow has velocity field given by velocity vector equal to 2 sine hx hyperbolic I cap plus v xy j cap. It is given that v at x comma 0 is equal to cos hx. Find the value of v at 0 comma minus 1. Now since it is a incompressible flow, we know that continuity equation says dou u upon dou x plus dou v upon dou y must be equal to 0. Dou u upon dou x from here, if you see, it is going to come out to be as 2 cos hx plus dou v by dou y must be equal to 0. Now from here we can say the value of v is equal to minus of 2y cos hx plus let us say some function of x, because we are integrating a partial derivative, we have to respect the fact that there can be a function of anything apart from y over here. Now that we have got this particular value, can we get the value of f of x? Let us put in this boundary condition. At y equal to 0, at any value of x, the value of v is equal to cos hx. If you put y equal to 0, this goes off. So we have over here cos hx is equal to f of x. That means the value of v over here becomes equal to. Now put this value over here, so you are going to have 1 minus 2y times cos hx. This is a function we are having. Small v is equal to this much. Now that we have got this value, the question is saying at x is equal to 0, y equal to minus 1. X is equal to 0 if you put, this becomes equal to 1, and y equal to minus 1 if you put, this becomes equal to 2 times minus 2 times minus 1 is 2, 2 plus 1 is equal to 3. The answer to this thing will come out to be equal to 3. So these are the 3 questions coming from fluid mechanics. Now 3 questions we are having from mechanics. Let us look at the first question, very basic question coming from the concept of equilibrium. The question looks very lengthy, but it's very simple. The question says, I'm moving out of the frame for you to see the question. The question says a rigid massless tetrahedron is placed such that the vertex O is at the origin and the other three vertices A, B, C lie on the coordinate axis in the figure shown. The body is acted on by 3 point loads. Mind you, 3 forces alone are acting on this particular body, okay, of which one is acting at point A along x axis. Now one is acting at point A along x axis. Let us say this is some force over here. Let us call this as F1. Other is acting at point B at y axis, in y axis. Let us say this is some force F2 we are having. For the body to be in equilibrium, the third point force should be at which point? Now you see 3 force member can be in equilibrium only if the forces are coplanar first of all. After being coplanar, the forces can be either parallel or concurrent. I don't see the 2 forces to be parallel, so they have to be concurrent and they have to be coplanar. Now look at the options. See, we are getting these questions out of memory of students, so the options may be wrong at some level. For example, the 2 options given over here are same, so both these options I'm assuming are wrong. Now if you look over here, the third force guarantee should be in this particular plane, that is in xy plane. So I see xy plane but not along x and y axis. This is correct. It is in zx plane, that is guarantee wrong. So answer over here is option C. Let us move further. Look at this question, very simple question based on work energy theorem. The question says a ram is in the form of a rectangular block of size length equal to 9 meter, width equal to 2 meter. It is suspended by 2 parallel ropes of length 7 meter. Assume center of mass of the body is at its geometric center and g equal to 9.8 meter per second square. For striking the object, let us say there is some object over here P. For striking certain vertical from which the ram should be released from rest. Now at what angle will I release this so that when it comes in the horizontal position it will acquire a velocity of 5 meter per second is the question. Now very simple, this body is undergoing pure translation, so I can say its gravitational potential energy is converting into kinetic energy. Let us say when it comes to the standard position, this is going to be 7, that means its initial height with respect to this as reference datum, it is equal to h. So I can say over here mgh must be equal to half mv square. Mgh is equal to half mv square. From here we can say the value of h is supposed to be equal to how much? V square by 2g. Now V square is supposed to be equal to 5, 5 square is 25, 25 by 2g is equal to 19.6. Now that I have got this particular value, the angle theta I can find is something like this. Now you see, if this height is equal to h, this is equal to 7 minus h, and this is 7, this angle is theta. The value of theta will be equal to cos inverse of 7 minus h divided by 7. 7 minus h divided by 7. If you do that calculation, you will get exactly 35.13 degrees. Let us round off to 35.1 degrees. So answer over here is option D, very simple question. Moving further to last question. The question over here, I am not having a statement for this question, directly I am taking a diagram. The question is saying you are having a 2-member frame formed in this particular format. Okay, you are having an internal hinge at this particular point B, you are having 2 hinge supports at A and C. 2 forces of values 100 kilonewton and 50 kilonewton are applied at the position shown. The question is asking what is the horizontal reaction at point B equal to. Now I can do one thing over here, I can find the horizontal reaction. I can find the horizontal reaction at any one of these ends, A or C. The same will be the horizontal reaction, let us say, at point B as well. The same will be the horizontal reaction at point B, because if you establish the equilibrium of a single member also, this point is experiencing horizontal and this point is experiencing horizontal. Now how do I start? Let us do one thing. I am going to take summation of moment about point A. For the entire structure, if I take summation of moment about point A equal to 0, what do I get over here? 100 and 50 are creating clockwise. Let us say this vertical is creating anti-clockwise. So I am having 100 times 3 plus 50 times 9 is equal to vertical times 12. Vertical at C times 12. From here I can get the value of vertical at C is equal to how much? 300 plus 750 by 12, let us say. Now that I have got the value of VC, now what I will do, look at this particular member. This member is BC member. At BC member I have this vertical force, I do not have the horizontal force. This vertical force is equal to how much? 750 divided by 12. I have over here a force which is equal to 50 kilonewton. Let us say I have some horizontal force over here, some vertical force over here. This is what I need to find out, HB I need to find out. Now what I can do is, these 2 forces I do not know, I do not want either. So let me take moment about this particular point. Let us call this point as some point over here, point O. So summation of moment about point O equal to 0 if you do. What are you going to get now? You are going to have HB is creating clockwise moment, 50 clockwise and VC anti-clockwise. So you have over here HB times 6 plus 50 times 3 is equal to 750 by 12 times 6. This is what we are having. Now 750 by 12 times 6 will be equal to how much? 375.5, let us say 375. 375 minus 150 will be equal to 225. 225 by 6 will be the answer. 225 by 6. That is 75 by 2, which will be equal to 37.5 kilonewton. Very elementary question from trusses and frames. It has come for 2 marks. And with this we close the syllabus for both fluid mechanics and engineering mechanics. Thank you and all the very best.
Hello everyone. In heat transfer, there are total 6 questions. So let's move to the first question. The wall of constant diameter pipe maintained at constant temperature in which laminar flow take place. Mean temperature Tm, flow takes place in the z direction, thermally fully developed. As you know, in case of fully developed, temperature may change, but the dimensionless temperature will not change. So if you see this option here, so you can directly go for C. The dimensionless temperature profile is unchanged in z direction. Next, laminar flow over a flat plate take place at a velocity u infinity and Nusselt number nu. The velocity of the fluid is double, the Nusselt number is. It's very easy, right? So nu directly proportional to r e raised to power 1 by 2 and Reynolds number is directly proportional to velocity raised to power 1 by 2. So if you do this, you will get root 2. Nusselt number directly proportional to Reynolds, Reynolds directly proportional to velocity under root, right? Simple question. Next, a hemispherical furnace of diameter 6 meter has an inner surface emissivity 0.7 of its roof maintained at 1200 while floor is black body. Okay, so this one is a floor 1 and 2. Everything is given. So what we need to find? We need to use this formula, T1 raised to power 4, T2 raised to power 4 by 1 minus epsilon 1 by epsilon 1 A1 plus 1 by A1 F12 plus 1 minus epsilon 2 by epsilon 2 A2. Routine problem, just substitute the shape factor and area, you will get the answer. Nothing is there in this question, it is framed like a previous gate. So use this formula, you will get the answer. Next, consider steady one dimensional heat flow in a plate of 20 mm thickness with a uniform heat generation of 100 watt per meter cube. The left and right faces are kept at 150 and 110. The plate has a constant thermal conductivity 200. The location of maximum temperature, it is same like a gate 2007 where this is the plate, right? So if you use the Cartesian coordinate system, you will get this equation, right? Qg x square by 2k plus C1x plus C2. So if you use the Cartesian coordinate, if you integrate 2 times, you will get this expression and just differentiate and equate to 0. Your answer is done. Nothing is there, nothing is there. This is x is equal to 0, T1. This is x is equal to L, this is T2. Put x is equal to 0, T is equal to T1, you will get C1. X is equal to L, T is equal to T2, you will get C2. If you do that, directly you will get this location and based upon this data, answer is around 6 mm. Answer is around 6 mm. So it looks to be lengthy, but it's repetitive. Cartesian coordinate, integrate, you will get equation, put the boundary condition, equate slope is equal to 0, your job is done. Right. Next, in a shell and tube type heat exchanger, contain one shell 20,000 tubes, steam is flowing at temperature 50 and mass flow rate 430. The latent heat is 2.32 megajoule per kg. Tube water is flowing at 1 kg per second, entering at 30, Cp is given. What is effectiveness? Effectiveness is Q actual by Q max, right? So this is your m dot HFG and this is C mean. So m dot C of C water, TH1 minus TC1. But make sure this Q max we are calculating for single, so here you need to multiply 20,000. Done. If you do this routine question, this is your actual heat transfer, this is C mean, Q max, this is C mean, m dot C Cc, TH1 minus TC1. So mass flow rate for single, multiply by number of tubes, you will get your answer. Very simple question, and of course effectiveness value less than 1. So answer should be less than 1. Next, consider one dimensional steady state heat conduction without heat generation in a plane wall with the boundary conditions shown in the figure. Thermal conductivity given K is equal to A plus Bx, where A or B causative constant. Now as you can see, as x is increasing, temperatures are increasing, right? As x is increasing, temperatures are increasing. This is T naught, this is T is equal to 0, this is T naught, right? So what is the temperature profile? As you need to understand, this is temperature 0, this is T naught. As x is increasing, temperature is increasing. So if you increase the x here, K is equal to A plus Bx. So as x increase, your K will increase. So as a result, dt by dx will decrease, right? So if dt by dx will decrease, so this will be the correct option, decreasing, right? So these are the question from heat transfer.
Yes, just see the production question, just see very easy casting question here. Aluminum is casted in a cubical shape, just see the dimension is given here for cube, that dimension is 20 by 20 by 20. Another mold material is used to cast a sphere of aluminum having diameter 20 millimeter. The pouring temperature for both cases is same. The ratio of solidification time of cube shaped mold to that of spherical mold. We have to calculate the solidification time. I am writing here the tau 1 by tau 2 is equal to m1 by m2 whole square. Okay, here we have to calculate the m1 and m2 here, that is modulus 1. 1 is what? That is the, here you can see that the m1 we can take for cubical shaped, cube shaped. Then what is the modulus volume divided by surface area? The volume is a cube. For the cube, the volume is a cube. 20 by 20 by 20, that is a cube, divided by 6a square. 6 into 20 square, you can see that this get cancelled, answer is 20 by 6. Then m2, you can see that the spherical casting, that I am writing the volume divided by surface area, volume is 4 by 3 pi r cube, but instead of r cube, here the diameter is given 20 millimeter, that is radius is 10, I am writing here the 10 cube, divided by surface area, that is a 4 pi r square, that is the 10 square. This get cancelled, this get cancelled. You can see here the answer is 10 by 3. Then I am putting that value here, that is m1 is here, m1 is 20 by 6, and m2 we can put here the 10 by 3 whole square. Then all get cancelled, and you can see the ratio of solidification time is equal to 1 only. Very simple question. Now see the next question. The allowance which is used to remove the material. The question is like that, the allowance which is used to remove the material, or also the allowance which is used to remove the pattern. I don't know the exact question. If the allowance which is used to remove the pattern, then the answer is shake allowance. Shake allowance is used for easy removal of pattern from the mold. Shake allowance. Yes, I think that the pattern is there. The allowance which is used to remove the pattern from the mold easily, then it is the shake allowance. Next question. For joining low carbon steel, we have to join the low carbon steel material by using the laser welding, or some students are also saying that gas metal arc welding. Which filler rod material can be used? If you are doing the welding of low carbon steel, then we have to use the low carbon steel filler rod. Then here, the correct answer is option C. Yes, next question. This is very easy question on the welding. Here the voltage is given, that is 30 volt. Voltage is given, that is a 30 volt, and you can see that voltage is 30 volt, the current is also given, the cross sectional area is given, welding speed is given, the heat required to melt the material, that is 20 joule per millimeter cube, small u is given, it is not joule per second, it is a 20 joule per millimeter cube. The percentage of heat lost, to the surrounding during the welding process. I am calculating here the melting efficiency, that formula is UA nu divided by eta Vi. Yes, we can put all the value. U is what? Heat required to melt the material, that is a 20. Area is given here. What is the area? Just see, area is a 20 millimeter square into the welding speed. Welding speed is 5 millimeter divided by eta. This eta is what? It is a heat transfer efficiency. It is not mentioned in question, then we can take it as 100%. Same ISRO question is repeated here. Last exam ISRO question is repeated here. Then I am taking 100% into V into I. Voltage is, you can see, the 30 volt, and here the current is 200 ampere. Then here we got the efficiency here 33.66, 33.33 percentage. They asked the percentage of heat loss to the surrounding. We got the melting efficiency. Then what is the percentage of heat lost? Percentage of heat loss, that is 1 minus this 33.33, that is the 66.66 is the correct answer, 66.67%. That is, we can do here the 1 minus 0.33, then we got correct answer, and here we have to give the answer in percentage. Yes, the preparatory codes in the CNC are denoted by which symbol? G codes are preparatory codes, G codes. Okay, M codes are miscellaneous, G is preparatory. Correct answer is G codes. Yes, now see, this is the example. Very easy. A cutting tool provided to tool life is 60 minutes. Here, the tool life I am writing here, the T1 is 60 minutes. Metal cutting question. While machining, with the cutting speed here, the V1 is equal to 60 meter per minute. Then when the same tool is used for machining the same material, it provides a tool life of 10 minutes. T2 is given here the 10 minute, and V2 is also given 100 meter per minute. 100 meter per minute. If the cutting speed is changed to 80, then V3 is, you can see, the 80 meter per minute. For the same tool and work material combination, the tool life we have to calculate, means we have to calculate the T3 here. Yes, then I am writing here V1 T1 raised to n is equal to V2 T2 raised to n. Put all the value of V1, V1 is 60, V1 divided by V2, what is V2 here, is 100, is equal to T2 by T1, that is a 10 by 60 raised to n. If you are going to calculate, you will get the value of small n, that is 285, 0.285 small n you will get. Here we got small n, but we have to calculate the value of T3 here. Then I am writing here V2 T2, V2 T2 raised to n is equal to V3 T3 raised to n. Then now again put that all value V2 by V3. V2 is, we have the available value 100, 100 by 80. Just check it once again, 100, 100 by 80. V2 by V3, 100 by 80 is equal to T3 by T2. We have to calculate the T3 here. T3, what is the value of T2? T2 is 10 raised to n. N is what? 0.285. Yes, calculate the value of T3. The T3 will be 28.87 minutes. Very easy question, easiest question on the metal cutting. Yes, now see the, we'll go later for this question, just see the next question. Which type of grinding wheel has best surface finish? You can see that the A60 number, A80, A54, A36, as the A number is higher, then it gives the good surface finish, where the higher number 80, hence correct answer is B. Okay, now see this question. Last question here, a flat surface of C60 steel having a dimension of 100 millimeter length and width. Length by width is given. Here the length, we require length only, I am writing the length 100 millimeter, and width is also given here the 200 millimeter. This is the workpiece length and width is given, is produced by slab mill cutter. 8 two-tiered cutter has 100 millimeter diameter and 200 millimeter width. Number of teeth given is equal to 8, and cutter has 100 millimeter diameter. This is the diameter of cutter, that is 100 millimeter and 200 millimeter width. The feed per tooth is given, that is 0.1 millimeter. The cutting velocity is 20 meter per minute. This is the cutting velocity is given. The depth of cut is denoted by small d millimeter. The machining time required is, we have to calculate here the machining time required. Then I am writing the formula here, the machining time is equal to L divided by feed. Okay, then L plus I am writing here the approach divided by feed is FTZN. Okay, then what is the length here? Length is given 100. Now how to calculate that approach? Then I am writing the approach is equal to in root small d, capital D minus small d. Here what is small d? Small d is 2. And what is the capital D? Just see the value of capital D is 100. Then I am writing 100 minus 2. Then its answer is 14. Then you can see here 100 plus 14 divided by FTZN, feed per tooth, 0.1 value. Here I can write the FT, 0.1 into Z is what? Number of teeth, that is 8 value, into N. We don't know the value of N, then we have to calculate N. I am writing here the V is equal to pi d N by 1000. The V is given the 20 is equal to pi d is the diameter of cutter 100 into N divided by not 60, it is 1000. Then we will get the value of N. I am writing that value of N is equal to 63.66. I am going to put here 63.66. Then calculate the TM, very easy. Here it is, I am writing the millimeter, length plus approach, and FTZN is millimeter per minute. Yes, then we get the answer in minute. Then here I am writing the machining time is equal to 2.23 minutes. This is the machining time. Okay, so all production questions are over. Thank you.
Hi students, now let us discuss the answers for thermal questions which are given in the today's GATE exam. Dear friends, this is the first time, right, very easy questions asked from thermal engineering. If you compare the last 10 years thermal questions in the GATE, right, these are very easy questions compared to other papers. So this time 6 questions asked from thermal engineering. Out of 6 questions, 2 questions for 1 mark and remaining 4 questions are for 2 marks questions. Okay, look at the very first question. Very first question is given on Rankine cycle. It is asked like this: which of the following statements regarding Rankine cycle is wrong? You are asked to decide the wrong statement, right? So first let us take the TS diagram for the Rankine cycle, right? TS diagram for the Rankine cycle is temperature versus entropy diagram. The saturation dome, this is the saturation dome, this is the boiler pressure, 1 minute, this is the boiler pressure PB and this is the condensation pressure PC. Generally we are allowing the superheated steam to the turbine, the 1 to 2 isentropic expansion followed by 2 to 3 constant pressure condensation, 3 to 4 isentropic pumping, 4 to 1 constant pressure heat supplied process. Okay. So for this Rankine cycle, right, we have clearly discussed in the class, right, the efficiency, thermal efficiency can be increased by first case by increasing the boiler pressure, right, and by increasing the temperature of the superheated steam and by decreasing the condensation pressure, and by decreasing the condensation pressure, we can increase the thermal efficiency of the Rankine cycle. Now look at the options. Look at the first option. Superheating the steam in the boiler increases the thermal efficiency of the Rankine cycle. Absolutely correct. Correct answer, correct option is not our option. Wrong option is our option. So anyhow, this is correct statement but not correct option. Look at the second statement. Cycle efficiency increases with a decrease in boiler pressure. No. By increasing the boiler pressure, thermal efficiency of the Rankine cycle increases. By decreasing the boiler pressure, thermal efficiency decreases, but it is given increases. This is a wrong statement. Wrong statement is our option. Option B is absolutely correct. Okay. Similarly, look at the another question which is asked. A furnace supplies heat to the heat engine at 1200 Kelvin with a magnitude 24,000 kilojoules per minute. What is the maximum work output? Here actually maximum power output of the heat engine when it rejects the heat to atmosphere at 300 Kelvin, right? Easy question. So for getting the maximum power output, the heat engine must be reversible heat engine. Take the reversible heat engine. For that reversible heat engine, heat is supplied from the hot source. This is the hot source is maintaining the temperature 1200 Kelvin. 1200 Kelvin. The heat given is Q1. The heat given is Q1. How much is given? 24,000 kilojoules per minute. It is giving the power output or work output. Then the heat is rejected to the cold source or atmosphere. The heat is rejected to atmosphere. Given atmospheric temperature is 300 Kelvin. The amount of heat rejection is Q2. You are asked to find the maximum power output. Very simple. For a heat engine which is operating between the two temperature limits, efficiency, reversible heat engine efficiency equal to, if it is operating between the two temperature limits, 1 minus minimum temperature by maximum temperature. It must be equal to what? Work output dividing by heat input. Heat input is Q1. From this, work output equal to Q1 into 1 minus T2 by T1. It is equal to Q1. Q1 is given 24,000 into 1 minus T2, 300 dividing by T1, 1200. Simplify this value for getting around 18,000 kilojoules per minute. But it is asked for maximum power output. For that, dividing by 60 for getting around 300 kilojoules per second or kilowatts. That is the option. Okay, that is the answer, right? Similarly, look at the another question. It is asked like this. A heat engine operating between hot source temperature of 1000 Kelvin and cold source temperature of 300 Kelvin. A heat pump is driven by the heat engine to have the cooling effect. It is given the heat pump, but that is for, according to memory based question, that heat pump is used for cooling effect, means that heat pump is acting as a refrigerator, right? The refrigeration space is maintaining 280 Kelvin and rejecting heat to atmosphere. That means both heat engine and heat pump or refrigerator both are dumping the heat to atmosphere. The total heat rejected to the atmosphere when the heat supplied to the heat engine is 150 kilojoules. The diagram is like this. This is the heat engine, right? This is the reversible heat engine. This reversible heat engine is receiving the heat energy from the hot source. That hot source is maintaining the temperature T1. The temperature maintained by the hot source is 1000 Kelvin. 1000 Kelvin. It is supplying Q1 amount of heat. That heat supplied to the heat engine is given at last as 150 kilojoules. 150 kilojoules. A part of the heat energy is converted to work energy. The remaining is rejected to atmosphere. This is atmosphere, right? The atmosphere temperature is given 300 Kelvin. The work output from the reversible heat engine is used for driving the heat pump. This is the heat pump. That heat pump is receiving the heat. That heat pump is receiving the heat from the cold space. That cold space is maintaining temperature T3 equal to, it is given 280 Kelvin, somewhere it is given 280 Kelvin. 280 Kelvin, the amount of heat received is Q3 and it is dumping the heat to atmosphere only. That atmosphere temperature is T4, that T4 of course equal to T2 equal to how much, 300 Kelvin. The amount of heat rejected by the reversible heat engine is Q2, whereas the amount of heat rejected by the heat pump, right, is Q4. You are asked to decide how much amount of heat is rejected to atmosphere by the both devices. So very simple, you are asked to decide Q2 plus Q4 is how much. That is the question, right? For that what you do, first you take the reversible heat engine. For the reversible heat engine, efficiency of the reversible heat engine equal to 1 minus T2, right? 1 minus T2 by T1, it is equal to work output divided by Q1. From this you decide the work output of the heat engine into 1 minus T2 by T1, right? You simplify all the values for getting the work output is 105 kilojoules. Then what is the heat rejected by the heat engine? Heat rejected by the heat engine Q2 equal to Q1 minus W 150 minus 105, that is equal to 45, right? 45 kilojoules. That is the heat rejected by the heat engine. Now come to the heat pump. Since it is acting as a refrigerator, though it is a heat pump, I am taking the COP of the refrigerator. By taking the COP of the heat pump also, you can find it COP of refrigerator equal to minimum temperature by, that is the minimum temperature is T3, right? Minimum temperature by T3 by T4 minus T3. It must be equal to what? Refrigeration effect. Here refrigeration effect is Q3. This is the refrigeration effect, right? Q3 dividing by work input. From this, right? From this I can find the Q3, the amount of heat received by the, right, heat pump as a refrigerator equal to W into T3 by T4 minus T3. This will give that Q3 1470 kilojoules. Then what is the Q4? Q4 equal to what? Q4 equal W plus Q3, right? Energy balance equation. It is equal to 1575. You see, you put the values. W already got it 105 and Q3 got it 1470, right? It is 1575 kilojoules. That is the heat rejected by the heat pump as a refrigerator. Then what is the total heat rejected to? Total heat rejected to atmosphere, this Q2 plus Q4. Q2 plus Q4 is equal to Q2 value I got 45 plus Q4 1575. Simplify this value for getting around 1620 kilojoules. That is the answer. That is the total heat rejected to the atmosphere by the both devices. Okay. Similarly, look at the another problem given for the Brayton cycle, right? The diagram is given like this. The temperatures at the respective points given. Temperate state 1 given, temperate state 2 given, temperate state 4 given, temperate state 5 given, and temperate state 6 given. But temperature at state 3 is not given. Temperature at state 3 is not given. So until unless the temperature at state 3 is not given, you cannot say that whether that system is working by ideal regenerator or not. If this T3 equal to T5, if T3 equal to T5 and T6 equal to T2, then only the regenerator, that regenerator is coming under ideal regenerator, right? For this particular problem, you cannot use the formula, the 1 minus T minimum by T maximum into Rp power gamma minus 1 by gamma. This formula you cannot use because it is not given that the regenerator is working by ideally. That formula can be used only when the regenerator connected between the compressor and combustion chamber is working by ideally or perfectly. So for this case what you do is you take the thermal efficiency general formula. Thermal efficiency general formula, net work output by heat supplied. This net work output, here work interaction is happening not only with the turbine but also with the compressor. The net work output equal to what? Expansion work, that is the turbine work, minus compression work. That is the net work output. The heat supplied, for finding the heat supplied equal to what? Cp per kg of the material, Cp T4 minus T3, but T3 is not given. For that what you do is you take the cyclic relation. So what is the cyclic relation? Cyclic integral del Q is equal to cyclic integral del W according to first law of thermodynamics for any cyclic process. Here cyclic integral del Q means heat supplied minus heat rejection is equal to cyclic integral del W means net work output. From this the heat supplied equal to the network plus heat rejection. Network plus heat rejection. So in the place of this heat supplied you write the network, right? Network means turbine work minus compression work plus heat rejection. Okay. Now per kg of the material, let me write the turbine work formula. The turbine work equal to Cp into T4 minus T5. Similarly, the compression work equal to Cp into T2 minus T1. Right, and the heat rejection equal to Cp into T6 minus T1. T6 is given. Once the exhaust gas dumped to atmosphere, the exhaust gas are dumping the heat to atmosphere. Therefore, the heat rejection to the atmosphere equal to Cp of the air into T6 minus T atmosphere. T6 minus T1 atmosphere temperature. Right? Then thermal efficiency. Cp will be getting cancelled on both sides. Here turbine work is T4 minus T5. T4 minus T5 minus compression work is T2 minus T1. T2 minus T1 dividing by the net work is turbine work minus compression work T4 minus T5. This part T2 minus T1 plus heat rejection. What is the heat rejection formula? Heat rejection formula is Cp T6 minus T1. Cp is cancelled. T6 minus T1. You put all the values. It is equal to T4. Look at the T4 value. T4 value 1250. Minus T5. Look at the T5 value. T5 value 800. Minus T2 value. Temperature after compression 550. T1 300. 550 minus 300 dividing by the same value in the denominator 1250 minus 800 minus 500 minus 550. You will be very careful while we are discussing in the limited space. 550 minus 300 plus T6. T6, what is the T6 value? 600 minus T1, 300. 600 minus 300. Simplify this value, right? It is 1250 minus 800, 450. Minus 550 minus 300. Without a calculator, you can do this problem. 250. 250 dividing by, right? 450 minus 250 plus 600 minus 300, 300. It is equal to 450 minus 250, 200. 200 divided by 200 plus 300, 500. Simplify this value for getting the answer 40%. That is the answer. 40% is the right, absolutely correct answer. Right. Similarly, look at the another question which is given under the what, compressible flow. Compressible flow. It is the MSQ type question. Right, MSQ type question. More than one options are correct. Look at the right first statement. Static pressure at point E. This is the normal shock wave. This is the shock wave developed somewhere in between E and F. Because of the normal shock wave, definitely pressure increases, density increases, entropy also increases. Right, but because of the shock wave, the pressure increases by drop of velocity. Therefore, Mach number decreases. Look at the statements. The static pressure at point E is less than static pressure at point F. Absolutely correct. Because of the shock wave or normal shock wave, definitely pressure is going to increase. Static pressure increases. Because of the increase in static pressure, definitely density increases. Density at point E is less than density at point F. Absolutely correct. Density at F is more than density at E. That is also correct. First statement correct, second statement correct. Look at the third one. Specific entropy at point E is less than specific entropy at point F. Absolutely correct. Because of the shock wave or normal shock wave, definitely entropy is going to increase. Look at the last statement. Mach number at point E is less than Mach number at point F. Absolutely wrong. Because of the shock wave or normal shock wave, what happened? The velocity decreases. Velocity decreases means indirectly Mach number is going to decrease. But it is given that, right, Mach number at point E is less than Mach number at F. No, right, practically Mach number at F is less than Mach number at E. D is not correct. A, B, C are correct. Okay. Look at the last problem. It is given like this. It is the cylinder with piston mechanism problem. Ask like this. Air is present in the cylinder with a piston mechanism as shown in figure. Air is there inside the cylinder. Right. Above the piston some weight is placed, and below the piston some stoppers are placed. The stoppers are there at a location 2 meters from the down cover, and the piston is there at a height of 3 meters from the down cover. What will be the specific work interaction by the time air is cooled to 25 degrees centigrade? That means indirectly he is asking what will be the work interaction by the time the temperature of the air inside the cylinder will be dropping from 350 degrees centigrade to 25 degrees centigrade. Okay. Dear students, for this case, until the air is cooled by the time the air is cooled by dumping the heat to atmosphere, what is happening? At constant pressure, since volume is directly proportional to temperature, by the time the air is cooling, temperature is dropping, along with temperature, volume occupied by the gas is decreasing. That volume occupied by the gas is decreasing at constant pressure until the piston is touching the stoppers. Once the piston is touching the stoppers, because of the further heat rejection, the volume of the material remains constant. That means it is the combined process of constant pressure heat rejection and constant volume heat rejection. The PV diagram I can mark like this. The pressure versus volume diagram I can mark like this. Until the piston reaches to stoppers, it is a constant pressure cooling process. 1 to 2 constant pressure cooling process. And 2 to 3, once the piston reaches to stoppers at constant volume, gas is cooling, here work done is 0 because here volume remains constant. Work for 2 to 3 equal to 0. Work for 2 to 3 equal to 0. Then what is the total work? Here total work equal to work for 1 to 2, work for 2 to plus work for 2 to 3. Here work for 2 to 3 is 0. Then the total work interaction equal to work for 1 to 2. Here 1 to 2 process constant pressure process. For a constant pressure process, right, PdV is the non-flow work. P into V2 minus V1, V2 minus V1. Since air is the material inside the cylinder is treated as ideal gas. For ideal gas, equation is PV equal to RT per kg of the material. Okay, sorry. It can be also written as, since 1 to 2 process constant pressure process where P1 equal to P2, that is equal to P, this I can write as P2 V2 minus P1 V1. It is equal to R into T2 minus T1, R into T2 minus T1. So R for atmospheric air, standard value 0.287, that is kilojoules per kg Kelvin. That is the what characteristic gas constant, not universal gas constant. T1 is given, but the T1 value, T1 is 350 degree centigrade, T1 equal to 350 plus 273, it is equal to 623 Kelvin, 623 Kelvin. So I know the T1 value, R value, T2 to be found. For finding the T2, you take the sorry, constant pressure process. At constant pressure, according to Charles' law, 1 to 2 process constant pressure process. At constant pressure, volume is directly proportional to temperature. Then I can say that V2 by V1 is equal to T2 by T1. T2 by T1. From that I can also write that T2 by T1 is 623 is equal to V1. Actually volume equal to what? Area multiplied by displacement or the gas occupied length. Then V2 can be written as A into L2 divided by A into L1. A cancelled. Finally T2 equal to 623 into L2 by L1. What is the L2 value according to given problem? Here L1 is the total length. L1 equal to total length is 3 meters. L2 equal to, after the piston reaches to stopper's location, the gas occupied length is only 2 meters. You put those values here. Right here T2 equal to 623 into L2 2 by 3. You simplify this value for getting the T2. My calculator has shown the T2 value 415.34. 415.34 Kelvin. That is the what T2. You put those two values for getting the total work. Here total work equal to work interaction equal to R 0.287 T2 415.34 minus 623. You simplify this value for getting the answer minus 59.6 kilojoules per kg. That is the answer. That is the specific work interaction by the time the gas is cooling to drop the temperature from 350 degrees centigrade to 25 degrees centigrade. So with this thermal problem completed, very easy problems. All the problems are easy only except the last problem. Last problem is needed calculator. The remaining all problems can be done without calculator also. I hope all of you successfully have written the GATE exam. With this we are concluding the today's session. All the best. God bless you. Okay, thank you.